A very good morning to you all. Today I am Srinivas. I will be speaking about the assigned seminar topic, that is synthesis of optically pure drugs. Today I will be covering the contents about my topic as optically pure compounds, stereoisomers. Among there are two types, that is enantiomers and diastereomers. I will be speaking about the enantiomers. Then synthesis of optically pure drugs. Then certain examples of optically pure drugs like synthesis of atenolol, then synthesis of naproxen, and advantages of this microbial synthesis of this optically pure compounds. Coming to optically pure compounds are those compounds that are capable of rotating the plane of vibration of the polarized light to the right or left direction. In the following slide, we can see the example of glyceraldehyde. The D and L notation of the glyceraldehyde is depicted, in which where if the light is rotated towards the left, then it is L notation, and if the light is rotated towards the right, then it is D notation, that is D glyceraldehyde and L glyceraldehyde. Stereoisomers. Stereoisomers are those isomers which have the same molecular formula and sequence of bonded actions, but they are known to differ in their three-dimensional orientations of their atoms in space, that is their arrangement in three-dimensional space. There are two types of stereoisomers. They are enantiomers and diastereomers. Coming to enantiomers are two stereoisomers that are related to each other by a reflection, means they are mirror images of each other that are non-superimposable. Coming to the R and S isomers, this this nomenclature system is useful for in enantiomer nomenclature. The R and R or S system is an important nomenclature system for denoting enantiomers. This approach labels each chiral centers, that is R or S, according to a system by which its substituents are assigned by a priority according to CIP rules, which is based on atomic number. Now coming to the synthesis of optically pure drugs, we know that optically pure drugs, they have the ability to the rotate the plane of light to either left or right. Now their applications in synthesis of the drugs that have got pharmacological activity or biological activity. Biocatalysis represents an important general approach to the synthesis of optically active compounds for a wide variety of applications like pharmaceuticals, herbicides, and pesticides. Optically pure drugs are more frequently preferred as they are known to show fewer side effects than the racemic mixtures, which are known to have both R and S configuration. Occasionally, enantiomers have completely different biological activities, and thus are instances in which the toxicity of racemic drug has been linked to one of the stereoisomers and the one without the desired pharmacological activity. Hence, there is need to separate R and S isomeric mixture to get the desired isomers which is having active pharmacological activity. For this, we are going to use the microorganisms uh, in order to separate the racemic mixtures to obtain one pure isomeric form which is having a high active pharmacological effect on our body. One example of optically synthesized pure drug through microbial synthesis is atenolol. Atenolol is an optically pure drug which is a beta blocker that is predominantly used to manage or in the treatment of abnormal heart rhythms or protect the heart from further cardiac arrest. That is one after attack of one after first attack, the second in the upcoming heart arrest, that time this drug is commonly given. It is used to treat angina, that is chest pain, and even hypertension. The use of bacteria to resolve the racemic mixture of a key precursor has enabled manufacturers to synthesize ethanol in large amounts, which is very pure and easy to obtain. The microorganisms that are mainly used in the resolving the racemic mixture of this ethanol are Nocardia species, Rhodococcus species, Corynebacterium species, and some Mycobacterium species. Now coming to the production, uh, as the precursor material for this is isopropylidine glycerol. With the help of selective microbial oxidation, that is what we have selected is that is Nocardia species or Rhodococcus species. They separate R and S isomers, and with the help of microbial oxidation, then there is one around four steps of the chemical synthesis with no isolation of intermediates. We obtain the atenolol. For this, the fermentation process involves as batch fermentation, which involves uh, media along with the aerobic process, aerobic, and operation is fed batch. And microorganisms used are Nocardia, Rhodococcus, Mycobacterium species. pH is maintained 6 to 7 and temperature is 30 degrees. By following the following parameters of the fermentation process, we can be able to go on with the uh, resolving the racemic mixture of the atenolol and thus obtaining uh, the main S isomer of that atenolol, which is having a biological activity. Now coming to the synthesis of atenolol, the physiological or the pharmacological activity of this compound is mainly associated with S enantiomers, that is S atenolol. It can be easily synthesized chemically, but uh, all the well, most of the chemical methods have certain other disadvantages. It is synthesized using optically active precursor, that is R12 iso R12 ortho isopropylidine glycerol. Racemic mixture of this R and S RS 1,2 ortho isopropylene glycerol is readily synthesized chemically. Then, with the help of the microorganisms like Nocardia, Rhodococcus, Corynebacterium, and Mycobacterium, they are able to oxidize the all the S isomer of this compound to R isomer, that is R12 ortho isopropylidine glyceric acid, and while leaving the R isomer unchanged, this transformation produces an equal mixture of R12 isopropylene glycerol and R12 isopropylene glyceric acid. The acid and alcohol are easily separated, after which the R12 isopropylene glycerol is converted to S-ethanol by a sequence of chemical reaction that was depicted in the previous reaction methods reaction chart. Coming to the advantages of this method, this microbial synthesis, in this case there is no intermediate is need to be isolated, and we are involving the microbes, so yield is high and also low cost, and there is less toxic or hazardous when we are comparing the synthesis of chemical methods. Coming to the next example, that is naproxen. Naproxen is a non-steroidal anti-inflammatory drug that is used to treat pain, inflammatory reactions, diseases such as gout, rheumatoid arthritis, and fever. Rheumatoid arthritis is a autoimmune disorder which can also be like treated to avoid the pain. It is available in immediate and delayed release formulations and is taken orally. Naproxen is a non-selective COX inhibitor. It appears to exert its anti-inflammatory action by reducing the production of inflammatory mediators called prostaglandins. It is metabolized by the liver to inactive metabolites. Coming to the synthesis is almost similar to that of atenolol by varying the microorganisms in which the resolving of the racemic mixture to obtain one pharmacological active isomer that has got biological activity. Chemical synthesis of this drug yields a racemic mixture of R and S naproxen, that is 6-methoxy alpha methyl 2 naphthalene acetic acid. In order to obtain pure S isomeric form from the racemic mixture of R and S naproxen, microorganisms are involved which are known to act by selective microbial oxidation, that is a type of biotransformation, and thus helps in obtaining the pure form of S isomeric form of naproxen. Naproxen has been produced by Syntex, one of the pharma firm in the USA, with the help of 2-naphthol as starting molecule or precursor molecule. Once the racemic mixture is obtained, then it is resolved with the help of microorganisms. The microorganisms commonly used are some fungi, namely Cordyceps militaris, Beauveria bassiana, Exophiala villansi, and Cladosporium resina. These organisms convert R isomer into S isomer and thus obtain the pure S isomeric form, which has pharmacological activity. The following is the synthesis chart. That is the main precursor material, that is 6-methoxy alpha methyl 2 naphthalenic naphthalene acetic acid in presence of microorganisms like Cordyceps militaris, Beauveria bassiana. Then conversion takes place to form S naproxen, which is having positive pharmacological activity. Coming to the uses of this naproxen, it is used to treat headache, body pain, arthritis, and fever also. It has anti-inflammatory activity. It may also have certain antiviral activity such as against the influenza virus, as it blocks the RNA binding groove of the nucleoprotein of the virus and thus prevents the formation of ribonucleoprotein complex, and thus take the viral nucleoprotein out of the circulation in order to avoid the further infection rate in the host cell. It is used to differentiate between normal infectious fever and also a neoplastic fever, which is malignant, that is known to be having some uh, cancerous tissues, etc. Side effects. Common side effects with this drug intake are dizziness, drowsiness, headache, rash, bruising, and some gastrointestinal upset. Coming to certain other drugs in which we can find the one isomeric form is active while the other one causes some harmful effects, like thalidomide is racemic. Thalidomide is a racemic drug in which R enantiomer is effective against morning sickness, that is one type of disorder, whereas S enantiomer is known to cause birth defects, that is having some around causing disorders. These are the S and R annotations of the thalidomide drug. And one more example of that drug is ethambutol. It is a racemic drug in which the S enantiomer is used to treat tuberculosis, whereas the R ethambutol causes blindness. About the enantiomers, which enantiomers are the one which are having mirror images of each other, but they are not superimposable each other. superimposable to each other. The example can be depicted with this uh, chemical structure that is given here. Coming to certain research articles regarding this my topic, uh, the main one the title of the research article, first research article goes on like this: the novel life is isolated from a pseudomonas strain that is G6, and its application in the synthesis of S 2-orthobenzyl glycerol 1 acetate. The authors are L. Kanwar, S. Hazarika, N. N. Datta, A. K. Hazarika, and Pranab Goswami. It was published in the year 2002. The main work the research authors they have did was a novel microbial lipase they isolated from the Pseudomonas strain G6, which had the catalytic synthesis ability of the synthesis of optically pure 2-orthobenzyl glycerol 1 acetate, which is the building blocks for the preparation of many beta blockers, which are known to be optically active. A Pseudomonas strain, that is G6 strain, which was recently isolated from the soil, produced an extracellular lipase, which was and the lipase produced was analyzed with the help of SDS phase, and it was found to be in the form of a hexamer in case of structure. The catalytic activity of the lipase was exploited for the synthesis of 2-orthobenzyl glycerol 1 acetate from 2-orthobenzyl glycerol through transesterification using vinyl acetate as acylating agent. The isolated lipases were effectively catalyzed the synthesis of 2-orthobenzyl glycerol 1 acetate from the corresponding diol by transesterification. The following uh, chemical reaction explains the research that is done by the authors. Coming to the next research paper, that is the title of the paper is microbial stereoinertion of R3, that is chloro 1,2 propanediol by one of the yeast, that is Vicar Hamomyces anomalus with strain MGR6KY209903, with the authors that is S. Kumarasamy et al. In 2020 itself. The main work that was done was the optically active R3-chloro-1,2-propanediol is useful for as a starting material for synthesis of variety of drugs and optically active compounds also. The authors they have been focused on the production of chiral compounds by the method of enantioselective selective microbial transformations of prochiral starting material with yeast. The preliminary assimilation was exercised with the Vicar Hamomyces anomalus MGR6 strain that was grown on synthetic medium, and it was observed for the assimilation by pH change in the medium. Yeast is most widely used for most number of bioconversions, and one yeast is like that is Vicar Hamomyces anomalus is a frequently found yeast species in natural environment like plants, soils, fruits, etc. The conclusion was that it was found that an effective method for preparing pure optically R3-chloro-1,2-propanediol was based on assimilating a degradation with Vicar Hamomyces anomalus MGR6KY209903, that is the strain. Coming to the last content, that is advantages of microorganisms in synthesis of optically pure drugs. That is, no intermediates need to be isolated in case of this one, and yield is very high. The cost in production with the help of microorganisms is low, and when compared to chemical synthesis, it is very less toxic, and the recovery rate is also high. It goes up to 6 to 92%, where it may not happen in case of chemical methods. And there is no reverse reactions like that happens in chemical reactions. And there is no also product inhibition. The references are that I have referred are Wikipedia slides here, and some of the uh, research papers, as well as some other websites. Thank you.